Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll look at translating graphs. So translate just means slide. So we'll be looking at translating them left and right and also up or down. Let's start off with an easy example. So on your screen is the graph of fx equals x squared. So what would be the graph of, say, f of x plus 2? Well, you're familiar with this notation already. If fx is x squared, for f of x plus 2, all I do is I take my x squared and I replace x with x plus 2. So let's graph that. Well, this one would have just one x-intercept at -2. So remember, if a parabola only has one x-intercept, it's also the turning point. So its y-intercept, if x equals 0, y would be 4, 2 squared, which is 4. So its intercept would be here. So this is what the graph would look like. So in black is the graph of f of x plus 2. So notwithstanding my imperfect drawing, these graphs are almost the same. The black graph is the same as the blue graph, except it's been shifted 2 along. Each point on the blue has been shifted 2 across to the left to get the corresponding point of the black. Okay, so maybe that was just a coincidence. What if we now graph f of x minus 2? So this, of course, would just be x minus 2 all squared. So this graph will have an x-intercept of positive 2, and like the black one, it will have a y-intercept of positive 4. So its graph will look like this. So again, my drawing isn't perfect, but the red parabola is the same as the blue parabola, but it's been shifted 2 to the right. So each point on the blue parabola, if you shift it 2 across, you get the point on the red, like this point. 2 to the right, you get to the red. Start at the blue, 2 to the right, you get on the red parabola. So we've discovered something now about horizontal translations. So this is what we found out. We found out that if you replace x by x plus b, x plus a number, this number in here tells you how much you shift across the x-axis. So both these cases, if the number is 2, we shifted 2 units. But it sort of went in the opposite direction than we'd expect. When it was x plus 2, when this number was positive, we shifted left. But when the number was negative, we shifted right. You'd expect the opposite to happen. So you're just going to have to remember that shifting left or right sort of goes in the opposite way that you'd expect. So if we take f of x plus b, it's the same graph as fx, but shifted b units across. And as I just said, if b is positive, you go to the left, negative, you go to the right, even though that's counterintuitive. So I showed you this for parabolas. It turns out it would work with any function. It would also work with cubics as well. So for example, if we want to graph y equals x minus 3 cubed, which we will do later in this lesson, it'll be the same as this graph, y equals x cubed, but shifted 3 units right. Because if this is f of x, this is f of x minus 3. So because this number's 3, we shift 3 units. And because it's a negative 3, that means we go to the right. Let's now look at vertical translations. So here again, we have the graph of fx equals x squared. What if we were to graph f of x plus 1? This time the 1 is outside the brackets. Well, that would just be the graph of x squared plus 1. So this would mean that every point on the blue would be shifted up 1. So this point here at 0, 0, that would get shifted up to 1. So if x squared is 0, x squared plus 1 is 1. And then next point up here would be shifted up, and so the graph would look like this. Now, I apologize, again, my drawing's not perfect. It might look like it, but these two graphs, the blue one and the yellow one, will never meet. So what if instead of graphing f of x plus 1, I graphed f of x minus 1? So that would just be the graph of x squared minus 1. And you know how to graph that. This one would actually have two x-intercepts at 1 and minus 1, and its turning point and y-intercept would be here. So its graph would look like this. So once again, none of these three parabolas will ever meet, will ever touch. So we've discovered that when I graph f of x minus 1, it's the same as the blue parabola, except each point has been shifted down 1. So this is the discovery that we've made. Compared with the graph of f of x plus some number will be the same graph except shifted up or down by c units. Now, vertical translation, shifting up or down, is easier because it does go the way that you'd expect. If this number here is positive, then we shift the graph up. If the number's negative, we shift the graph down. So once again, this would work for any graph, not just parabolas. So for example, the graph of y equals 2x cubed minus 5 is the same as the graph of y equals 2x cubed, except shifted down 5 units. Because these are essentially the same equation, except there's minus 5 on the end here. That minus 5 shifts it down. So this is useful when we're graphing things like cubics or quartics, because if we know what this graph looks like, we can draw this graph easily. And that's what we'll look at in the rest of the lesson. All right, thank you so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.